graders wanted to solve a real-life problem. They wanted to know the height of the flower. The things that they had access to were measuring tape, duct tape, a protractor, string, and a paperclip. The first thing that they needed to do was measure the distance between the observer to the base of the flower. And then they also needed to measure the observer's height. Then they could use the protractor to measure the angle from the observer's height at eye level to the top of the flower. So the fifth graders have the angle of theta to be 24 degrees. They have the height of the observer at eye level to be exactly 4 feet or 48 inches, and the distance between the observer to the base of the flower is 180 inches. The boys then pondered over what they could do to solve the problem. If you multiply the distance times the tangent of the angle that the boys found, they found that the height of the flower from eye level was 80.1 inches. Thus finally, 80.1 inches plus 48 inches equals 128.1 inches. We can then divide that by 12 to get our units in feet, and that gives us a total height of 10 feet 8 inches as the height of the flowers. The fifth graders had reached their goal. Our fifth grader is now going to run 10 sidewalk blocks, but the first thing we need to do is really measure how long that sidewalk block is, and we found out that it's 86 3/16 inches. We then converted that to a decimal, and then we just need to find the rate by taking our distance and dividing by the length of the run. But we really need to get our run before we can actually find the rate. And we found the rate to be 6.52 seconds. We are including pictures of the starting line and the finish line so that if you go to Google Earth, you can actually try and compare the distance that was run. Just search for Franklin Park, Missoula, Montana. The rate is then the distance of one block times 10, because there's 10 blocks, then that divided by time, which gives us a rate of 132.2 inches per second. We can then convert that to feet by dividing the rate by 12, which gives us a rate of 11.02 feet per second. A useful conversion would be miles per hour. So first we're going to multiply by 60 seconds per minute, and again by 60 minutes per hour to get 39,656.8 feet per hour. There are 5,280 feet in a mile, so we're going to convert that by dividing the feet per hour rate by 5,280 feet per mile, which gives us a rate of 7.51 miles per hour. That concludes our fifth grade activities. So get out there, do some triangulation, get out there and just run and find out what your rate is. I've also included enough hints so that you can go to Google Earth and go to Franklin Park, Missoula, Montana, and you can actually see how accurate Google Earth is on its measurement tool.